Am I audible, beta?
Yes, ma'am. Yes, ma'am.
Okay then. See, Dhananjay, in permutation, what we were doing? Any idea? Tell me, beta.
Yes, ma'am. What?
In permutation, what we were doing?
Finding the number of a case, maybe.
See, in permutation, the each of the arrangement which can be made by taking some or all the numbers of object, right? So in this way, you were in that way, you were using permutation. Now in combinations, what is combination? Each of the groups, or you can say selections, which can be made by taking small or all the objects, all the number of objects, without reference to the order of objects. Each is called a combination. Okay, see, suppose combination when all objects are different. Combinations, how you will select when all combinations? When all objects are different. So there are few criteria. So the formula is NCR will be equal to n factorial upon n minus r factorial into r factorial. What was NPR? It was n factorial upon n minus r factorial. Have you remembered, Dhananjay?
Yes, ma'am.
So when objects are different, then you will take your combination as NCR is equal to n factorial upon n minus r factorial into r factorial. So for example, suppose if you have to find NC5, find n if NC5 is equal to NC7. So how will you find? Any idea, Dhananjay?
Ma'am, substituting the value with combination formula.
Yes. So you will write n factorial upon n minus 5 factorial into 5 factorial, right? And it will be n factorial upon n minus 7 factorial into 7 factorial. Okay. So n factorial cancel. Then you can write n minus 7 factorial upon n minus 5 factorial is equal to 5 factorial upon 7 factorial. Can I write like this?
Yes, ma'am.
I have transposed this here and this here. Okay. So now 9 minus 5. So you can write 9 minus 7 factorial upon 9 minus 5 into 9 minus 6 into 9 minus 7 factorial, right? And 7 into 6 into 5 factorial. So 5 factorial cancel, and minus 7 and minus 7 cancel. Right, beta?
Yes, ma'am.
So you can cross multiply. Then n minus 5 into n minus 6 will be equal to 7 into 6. So see, your numbers right hand side. So here left hand and right hand side, both are in with sequence. Here see n minus 1 into n minus 2. So you are subtracting 1 from this minus 5, you will get minus 6. So 7 minus 1, 6. So on comparing, n minus 5 is equal to 7 and n minus 6 is equal to 6. So value of n will be 12 from both the values. You will get value of n as 12. Got it, beta?
Yes, ma'am.
Please notice.
Ma'am, I took a screenshot. I will note it later.
Okay. You are not having notebook.
No, ma'am. Actually, I should leave a bit early today. So,
Okay. Now suppose this is the, now this question, next question. You are out of station.
no, ma'am. I need to go out now in
Okay.
like half an hour or something.
Okay. So from a class of 36 students, question is like this: from a class of 36 students are to be selected to take part in a competition how many such selections can be made? Solution is, see, now how many students are there? 36, right? How many children you have to select? 3 students. From a class of 36 students, 3 students are to be selected. So how many students you have to select? 3. So you will apply combination 36 C3. Got it, beta?
Yes, ma'am.
And suppose how many committees of 5 persons with a chairperson can be selected from 12 persons. So tell me. Tell me, Dhananjay, any idea you can give for this question?
Ma'am, 12C5 maybe.
See, chairperson will have separate post.
Yes, ma'am.
And committee members are different, right?
Yes, ma'am.
So 5 persons you have to select, right? See. And 12 persons. So it means this, suppose this is a post for chairperson. Okay. So from this 12%, 12 are eligible or not?
Yes, ma'am.
So number of ways to select a chairperson. It will be 12.
Yes, ma'am.
So now, after selecting chairperson, how many members we have to select? 1, 2, 3, 4? 4 members.
Yes,
And
ma'am.
1 person we have selected. So now total persons are 11.
Yes, ma'am.
And we have to select 4 committee members. So number of days will be for select 4 members. It will be 11C4.
Yes, ma'am. Yes.
So number of ways to select committee members with chairperson. With chairperson. It will be 12 multiply 11C. Got it, beta? Now you can open this. 12C4. So you will write 12 into 11 factorial upon 11 minus 4, 7 factorial into 4 factorial. Now you can solve, beta?
Yes, ma'am. Ma'am, is it 7 factorial, ma'am?
Yes, beta. This is 7 factorial. Okay, suppose if I'm asking you question, determine the number of ways of choosing 5 cards out of deck of 52 cards, which includes exactly 1 ace. So how you will solve? Dhananjay,
Yes, ma'am.
any guess?
Ma'am, 48, 48C4, ma'am.
And we have to select 5 cards. We have to choose 5 cards, huh?
Yes, ma'am. Ma'am, 48C4 into 4C1.
Can you explain me?
Yes, ma'am. In a deck of cards, there are 4 aces.
Yes.
1 minute. And in 5 cards, we'll get 1 ace. It's given in question. So 4C1.
Okay. Good. See, determine the number of cards choosing 5 cards. We have to choose 5 cards out of 52 cards. So we know that 52 cards are combination of 48 plus 4. So 4 aces are there and 48 are non-aces. So if we are selecting all 4, because it has written exactly 1 ace. So in 4 cards, it will be 4C1. Right? Now we have to select 1 more. So rest cards are 48. So 48C4. Right, beta?
Yes, ma'am.
Okay. Now next is. So find number of ways of choosing 4 cards from a pack of 52 playing cards in how many of them, how many of these? First is cards are of same suits. Second is two are red and two are black cards. Third is cards belongs to different suit. Solve it. Just give me 2 minutes. Done, Dhanunjay?
Ma'am, I got only second one, ma'am.
And first?
Ma'am, first I didn't get, ma'am.
Okay. Actually, in first part, okay, I'm explaining. See, in first part, it is given that cards are of same suit. It means suits are heart, spade, diamond, and club. Right, beta? And each suit has how many cards? 13 cards or not?
Yes.
Right? So same suits cards we have to choose and we have to pick 4 cards. Right? So number of ways of same cards will be, see, spade, club, diamond, and heart. How many suits are there? 4.
Yes, ma'am.
So number of ways of choosing one suit, because card will be same suit now. So we will choose only one suit. So it will be 4C1 or not? Out of 4, we will choose 1.
Yes.
Right, beta?
Yes.
Now in one suit, how many cards are there? 13?
Yes.
Yeah. So number of ways of choosing card, it will be 13C4 or not? Out of 13, we have to select 4. Right? So total
Yes.
number of ways will be 4C1 multiply 13C4. Have you understood this part, beta? Because we have to select all 4 cards from, suppose, heart, diamond, spade, and club. So out of 13, we will select 4 cards, right? And
Yes,
suits
ma'am.
are 4, and we have to choose one suit. So there are 4 suits. So you will choose one suit from 4. So 4C. Got it?
Yes, ma'am. Got it.
Yes. Now second part is of 2 are red and 2 are black. So what is the solution?
Ma'am, 26C2 into 26C2.
Yes, 26C2 and 26C2, right? Because black color cards are also 26 and red color cards are also 26. Very good.
Yes.
And fifth, last part, cards belongs to different suits. Not done?
Ma'am, I didn't solve it, ma'am.
Okay, see. So suits are spade, club, diamond, and heart. And 4 cards we have to select. Suppose 1, 1, 1, 1. Right? And these cards are 13. These are also 13. These are also 13 and these are also 13. So total number of ways will be 13C1 multiply 13C1 multiply 13C1 into 13C1. Clear? Clear, beta?
Yes, ma'am. Clear.
Because all cards should be of different suits. So multiply 13 into 13, 169. 169 into 1. It will be 28,560.
Yes,
Got
ma'am.
it?
Oh, yes, ma'am.
Now suppose I'm giving you question like this. Find the number of different words. Find the number of different words that can be formed from the letters of the word intermediate. Such that two vowels never come together. Any idea?
No.
Okay. Firstly, write the consonant separately. So consonants are T, T. Two T are there. Then N, right? R, M, and D. Right, beta? And vowels. Vowels are I, E, E, and A. Clear?
Yes, ma'am.
So see. So how many consonants are there? 6. So number of ways to arrange consonants is 6 factorial. Now see, two letters TT are repeating, beta, right?
Yeah.
So you
Yes.
will divide it by 2 factorial because two letters are repeating. So you can solve 6 into 5 into 4 into 3 into 2 factorial divided by 2 factorial. 2 factorial cancel. 6 5s are 30. 30 4s are 120. Then 360. Got it this the point?
Yes.
Okay. Now next is we have arranged the consonants. Now no two vowels come together. They are saying no two vowels. Now see how many vowels are there? 6. Number of ways of arranging vowels. So 6 vowels are there. So 6 ways. 6 factorial. Now 2 I's are repeating. So divide by 2 factorial. 3 E's are repeating. 3 factorial. Got it this point?
Yes.
Now it will be 6 into 5 into 4 into 3 factorial upon 3 factorial into 2. 2 2 ja 4. So 60. Got it this thing, beta?
Yes.
Yes. Now see. So we have to arrange it, right? So 6 consonants were there. Right? Now we have to no two vowel come together. Right? So you can mark 7 cross. This is vowel, this is vowel, this is vowel, and this is vowel. Because they will not come together. Right, beta? Here also I can put vowel and here also I can put vowel. Or not?
Yes, ma'am.
Cross represent vowels. So, how many places are for vowels? 1, 2, 3, 4, 5. Just 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and 7. So 7 places are for vowels. And out of 7 places, you have to select how many places? 6 places has to be covered. Right, beta? Because
Yes.
we are having only 6 vowels. So total number of ways. So it will be 7, 6, 7 C6.
Yes, ma'am. 766.
So 7 into 6 into 6 factorial upon 6 factorial into 1 factorial. So it will be cancel 7. So total number of ways will be, first was 360, then 60, then multiply by 7. Now multiply them. 6, 7, 42. 42 into 36. 1512 and double zero. So number of ways will be 1,51,200. Clear, beta?
Yes, ma'am.
So may I tell you a little bit about binomial theorem?
Yes, ma'am. I have still 5 minutes. Ma'am, in 5 minutes I need to leave.
Okay. Then binomial theorem. See, beta, in binomial theorem, what we can do, where it is applicable, do you know how to expand this x to x plus 10 raised to the power 10? Can you expand it?
No, ma'am.
So we can expand till, I guess, y quadratic.
Ma'am, I can tell 2 quadratic only, ma'am.
Quadratic, y quadratic, right?
Yes, ma'am. I can.
Yes. Now we can't factorize it. Suppose we know that a plus b raised to the power 0 is 1. A plus b raised to the power 1 is a plus 1 b. A plus b whole raised to the power 2. You can expect a square plus 2a plus b square. And a plus b cube is, you can write it like this, a cube plus b cube plus 3a square b plus 3b square, 3ab square, right?
Yes.
And a plus b whole power 4, you can expand it like this, a plus b whole square raised to the whole square, right, beta?
Yes, ma'am. We can write.
So it will be a to the power 4 plus 4a cube b plus 6a square b square plus 4ab whole cube.
Yes, ma'am.
And plus b4, right? So total number of term in each expansion is 1 more than the index. See, here index was 2 and number of terms after expanding is 3. Here is 3. After expanding, how many terms you have got? 4. Here is power is 4 and how many terms you have got? 5. Right, beta?
Yes.
So in each of the expansion, the sum of indices A and B is same. A plus B is how much? 2. A plus B. Okay. So sum of the indices A and B is 3. So what is your binomial theorem? Binomial theorem is basically, first of all, NC0, NCN, this is equal to 1 by binomial, by your combination, which we have studied earlier. And binomial theorem is basically A plus B whole raised to the power n. This is the general formula. NC0, A raised to the power n, plus NC1, A raised to the power n minus 1. You will start writing B. Then NC2, A raised to the power n minus 2. B square plus NC3, A raised to the power n minus 3. Up to so on, NCN, B raised to the power n. See how it works. Suppose value of n is 2. So A plus B raised to the power 2 is equal to, now put the values. So 2C0 beta, A raised to the power 2 plus 2C1, A raised to the power 2 minus 1 into B plus NC2, 2C2, A raised to the power 2 minus 2 into B square. Clear? Now open it. 2C0 is 1. So it will be A square plus 2C1. It will be 2 AB plus 2C2 1. NCN is equal to 1 always. So 2C2 is equal to 1. 2 minus 2 is equal to 0. So B square. You will get this expansion, na? A plus B whole square.
Yes, ma'am. We get it.
So this is the general formula to expand any expansion, right? Or you can generalize like this. A plus B whole raised to the power n. You can write summation. R is equal to 0 to n. NCR, A to the power n minus R, B to the power n. Okay, beta. So by using this formula, you can expand. Suppose I will ask you that expand 7x plus 2y raised to the power 11. So what is the value of A? A is 7x, B is 2y, and n is 11. Okay, beta? So just apply this expansion. So 11C0, A to the power, not A, 7x to the power 11. Plus 11C1, 7x raised to the power 10, 2y raised to the power 1. So both powers sum will be 11 only. So 11C2, 7x raised to the power 9. So now the powers of A, or you can 7x, will descends. Okay. And power of B will ascend. Okay, beta? So it will be 2y raised to the power 2 plus 11C3, 7x raised to the power 8 and 2y raised to the power 3 plus 11C4, 7x raised to the power 7 and 2y raised to the power 4. So in this way you can solve. Okay, beta?
Yes. Okay.
So this exercise only involves this formula. Okay?
Okay.
And Dhananjay, best of luck for your 11th class, beta.
Thank you, ma'am.
I hope you have learned what we have taught you.
Yes, ma'am.
Yeah. And it was very pleasant for me also to teach you. Okay?
Yes, ma'am. I am also thankful to you, ma'am.
Yes. Okay. We are also thankful to you, beta, because you are interacting with me and you are asking your doubts and you are sending your solutions on also. Okay? So you
Yes.
can don't think this thing that now bridge course is over, so I can't ask anything. You can ask me anything. Okay?
Thank you.
Related your life. Okay? I will be there. Bye-bye, beta. Best of luck for your
Yes, ma'am.
future. Yeah.
Yes, ma'am. Thank you, ma'am. Have a
Okay,
great
beta. Bye, bye.